Bismillahirrahmanirrahim. The concept of a sine wave. Of course, the repetition of any instance is a function of waves. We have three types of waves. As we can see, we have what we call the sine wave, which is the most important, and we have the sawtooth wave and the square wave, as we can see from the figure. The most important, as we said before, is the sine wave, because any complex wave is made of different sine waves. The change in pressure in sound waves, as we can see, occurs in ultrasonic. As we can see, there is a change in the pressures. We have two types. We have an upper zone of pressure and lower zone of pressure, as you can see from this sound waves reaching to the listener. Regarding the change, of course, of the variety of the variation, the electrical and magnetic field occurs in case of electromagnetic radiation, such as light. So we have light and sound as a wave motion. Of course, we can create the sine wave by moving a wire through a magnetic field. As we can see, these movements create the alternating current. So this movements creates the sine wave. As you can see, this is a complete sine wave. It creates around 360 degree. On the other hand, we can create, of course, the sound, the sine wave by using the crankshaft. The crankshaft is a shaft attached to a crank. As we see, it is something like a wheel. This is attached to the piston of the car. So whenever this shaft descends downwards to a certain level, this attachment is on the periphery of the wheel, not in the center of the wheel. So this point of descent and the center of the wheel creates an angle. This angle we can induce the 4/4 of the 360 angle. See, of course, this angle can estimate the hypotenuse of this right angle triangle. Characteristic of the sine wave, we have three characteristics. Well, first of all, the phase. As we said before, we have upwards and downwards phase. This complete phase creates what we call the 360 angle. Whenever the waves goes through, as we can see, it creates the angle, and this is the crankshaft going down, creating the angle. Of course, if this waves are out of phase, of course, it will create a straight line. So this is the first thing. Regarding the phases, we have an upwards and downwards, creating a 360 degree. The second thing is the wavelength. As you can see, of course, the wavelength and the amplitude. The wavelength is the distance between two similar points, as you can see. And the amplitude, of course, is the height of the wave, as you can see. In case of sound waves, whenever we have a large amplitude, it creates a loud sound, and we have a low amplitude, it will create a quiet sound. Regarding the light waves, we have a large amplitude creating a bright, and we have a small amplitude creating a dim view. So this is the difference between sound wave and light waves regarding the amplitude. Now we come to the frequency, period, and velocity. Of course, you ought to know that the velocity means the frequency times wave length. You see, so the frequency of wave, of course, is being recorded as hertz. As you can see, whenever I see we have 10 cycles per second, we call it 10 hertz. So this figure shows 4 cycles in 1 second. That means that each cycle will expand for around 1/10 of a second. You see, of course, if as we know, the velocity of sound is fixed, and if frequencies increase, definitely the wavelength will be decreased. Of course, this difference in frequency regarding sound waves will create the difference in the pitch. So we have high pitch and low pitch sound waves regarding the frequency. You see, now we come to the light wave. We never have a high frequency. It is shown as red, and if we have a high frequency in the short wave, it will create a blue, and a longer wavelength appears red. There are many types of electromagnetic waves in the electromagnetic spectrum. This is a chart showing the electromagnetic spectrum, which has different types of waves. We have waves regarding the frequency and the wavelengths. We have, of course, differently the X-rays, and we have the infrared, and have the oximeter. All these are types of wave. And of course, we have the gases whenever they emit electromagnetic radiation, whenever they are excited. Of course, this creates wave. We can notice from it the type of the gas, as we mentioned before. The Doppler effect, as we said before, sound waves have a high pressure region and a low pressure region, as we can see. This is an object going far from the listener. He appreciates the low pitch of the sound, and whenever it reaches nearby to the listener, the frequency increases and the pitches increase. This makes him hear much better. Of course, sound waves are made of piezoelectric. We can use only one piezoelectric, but this makes me maneuver too much to and fro so that I can explore the picture. But if the piezoelectrics are made in one line, it can visualize much without can visualize much of the picture with less movement. The drawbacks, as we can see, that we can use, of course, the ultrasonography to denote the distance of the region I'm trying to discover. Of course, the change of the density between the areas and the inclination light angle makes the difference. So this dips can be identified by ultrasonography. As we can see, we can detect the movements of the RBCs in a limb by receiving and emitting pencil-like source. So this reflection of waves can denote the flow through this blood vessels, and we can, of course, this change in the density of the tissues and the reflection of the ultrasonic creates a picture. So this is how we can see the baby's heart during the manipulation. Of course, we have many uses of ultrasonography. It can be used to induce heat in physiotherapy, but sometimes whenever we use high energy, it creates a very low pressure and creates what we call a cavitation. Now we come to what we call interference. And this is the most important point in this subject, is the refractometer or the interferometer. Of course, it's based on the refractive index. Whenever light is being subjected to a combination of, suppose, oxygen and hallucine, this reflection of light through this concentration can be notified and compared to a similar reference to identify concentration of the hallucine in the sample. So we have two rays. One of the rays goes to the sample chamber where we are putting hallucine and oxygen, where we want to know its concentration. The other one is the reference where we don't have anything, suppose. So these two streams are being subjected, of course, to light. This light emitting from each stream is going to be reflected by a semi-silver mirror, as we can see. One of them is fixed, and the other one is movable. You see. So the point is, whenever two waves are in the same phase, they are collected together, and they create what we call, as we can see, the two are in the same. It creates a potentiation. It creates what we call the bright fringe. You see. So the amplitudes increase. If they are out of phase, they will they will create what you call the dark fringe. So we have two fringe we ought to know according to the concentration of halocene. So of course, the concentration of halocene in this area will be different from that in the sample one, and then we move the mirror by our eyes. As you can see, it's not written much in the subject, but the movement of the inclined mirror, as we can see, to adjust so that the two of the picture are similar. This reflection difference can denote the concentration of halocene present in the sample. Of course, so we can use it to identify other gases, but we ought to know as the mass spectrometer the components of the gas. So it does not identify the types of gas. Of course, we have it is non-specific because it's not specific for halocene. On the other hand, we have, of course, portable small refractometers to be used in the theater. Of course, we have what we call the interference filter. Interference filter is made a block of material. This block of material is coated by special layers. This thickness of the layer is correlated to the frequency of the wave that I want to identify, or the wave that I wanted to pass through this coated area. You see, this is a correlation. Of course, as we know, the deflection of the wave from an area depends upon the media and the wavelengths of the inclined rays, and of course on the angle of the transmit. All these are the factors that create the reflection. So this is a hint about what's the meaning of the filters. These filters, of course, are used to create a wavelength for infrared analyzer or for carbon dioxide measurement. And frequency spectrum, of course, there is spectrum. Spectrum means an ordered array. As we can see, these are spectrum, different frequency. As example, of course, we have the ECG is composed of range ranging from 0.5 to 100 hertz. So it's a very large range. And we have a slower EEG. We have from 1 to 5 hertz. And these are 4 types of the EEG. Of course, you have a faster beta in such an EEG. Of course, we have the spikes present in the electromyography. These spikes means there is a high frequency of waves. Of course, any complex wave, as we can see, all these are sine wave creating a complex wave. This complex wave, as we can see, can be analyzed through what we call Fourier analysis. This separates this complex wave into different sine waves. And this is the picture we're showing the refractometer where this lady is having a look to adjust so that she will know the concentration of the gas present. I hope that I accomplished my mission in a very little time. Wassalamu alaikum wa rahmatullahi wa barakatuh.